So hello everyone. So basically in this topic of Euclid division lemma, we have seen this one about 2m. Okay. Now so in this question they have asked it, show that any positive integer is of the form 3m or 3m plus 1 or 3m plus 2. So how will you do it? Very simply. So let n be any integer. Okay. If we divide n by 3, then let's say q be the quotient and r be the remainder. So from Euclid division lemma, we can say that n is equal to 3. 3 was the divisor. 3 into q plus r. Okay. And we know that 0 less than equal to r less than equal to the divisor 3. That means the value of r is 0, 1, 2. It cannot be 3 because it's less than 3. Okay. So we can write n is equal to 3 into r plus 3 into q plus r. So if we replace the value of r as 0, 1, 2, then we will get n is equal to either 3q or 3q plus 1 or 3q plus 2. So this is what they have asked. So any positive integer is in the form of 3m, 3m plus 1 or 3m plus 2. Here they have used m, I have used q. Okay, the answer is here. Now, they have also asked any positive odd integer is of the form 4m plus 1 or 4m plus 3. Odd integer. Have you noticed odd integer? And it's 4m plus 1, 4m plus 3. So basically there is a very good hint. 4m. Here is 3m. So the digit which is along with m. So this is basically the divisor. So in this question of 4m, you divide n by 4. Then what will be the remainder? 0 less than equal to r less than 4. That means 0, 1, 2, 3. So in the second question, the r will be 0, 1, 2, 3. Okay. Now, if we replace, here this one is 4. If we replace r by 0, 1, 2, 3, then we will get this one as n equal to 4q. Or, let me write it here, n equal to 4q. Or, n equal to 4q plus 1 or 4q plus 2 or 4q plus 3. But have you noticed here they have asked about any positive odd integer. Listen, check out 4q and 4q plus 2. These both are divided by 2. That means these both are even integer. See, 4q plus 1, 4q plus 3. These two are the only digit that is not divisible by 2. That means they will have something as remainder. This means these are odd integer. Thus, any positive odd integer is of the form 4m plus 1, 4m plus 3. So here is the required answer. And the detailed explanation is this one. Now, there is another question. Any positive odd integer is of the form 6m plus 1, 6m plus 3 or 6m plus 5. So how will you do this one? What I have said. The number which is along with m is the divisor. So here it is given as 6. So 6 is the divisor. So let n be any arbitrary integer. So on dividing n by 6, we will get q as quotient. Or if you want, you can take m also. If you want, let's say m. So on dividing n by 6, we will get m as quotient and r as remainder. So from Euclid division lemma, n is equal to 6 into m plus r, where r is 0 less than equal to r less than equal to what? 6 less than equal to the divisor. Okay. So less than equal to 6. So what is the value of r? 0, 1, 2, 3, 4, 5. That's it. It will not be equal to 6 because it's always less than. It is always less than b. Okay. So what they have said? Odd integer. So for odd integer, notice this one, 6m plus 2 and 6m plus 4. These three terms are divisible by 2. That means these are even integer. So what we are left with 6m plus 1, 6m plus 3 and 6m plus 5. These three integers are not divisible by 2. That means they are not even. That means they are odd. So this is the answer.